Impressive success of convolutional neural networks sparked the tendency of image semantic processing using deep learning techniques. In image feature description, CNN models outperform the well-established handcraft and machine learning features. Features extracted with CNN models are commonly referred as image semantic features. The term semantic feature has been widely studied in the field of linguistic semantics and defined how human beings represent the meaning. Although CNN description models stand for the image semantic feature using a range of different approaches, none of these models coding the visual semantic information using a theoretical foundation of cognitive science to represent the semantic meaning. Prototype theory exposes that semantic representation of category is related to the category prototype. Human beings think categories in terms of semantic prototypes and organizes the category members around its central semantic meaning. Category prototype is included in cognitive processes, and consequently, categorization is made based on how similar a new exemplar is to learned prototypes. But how can the semantic of category prototype be included in object global semantic description? Motivated by the human approach for describing objects, in this paper we propose a novel approach for global semantic descriptions that uses the generalization and discrimination processes to make object descriptions that highlight their most distinctive features within the category. Our prototype-based description model uses well-known classification models to categorize the objects and use prior learned prototypes to find object features that make it distinctive within the category. To achieve this goal, we rely on cognitive semantic studies related to the prototype theory for modeling the central semantic meaning of category, the prototype. We propose a straightforward approach to encode and store object categories prototypes using CNN classification models. The figure shows an overview of our prototype-based description model. We show a set of steps to transform the visual information received as input into a global semantic descriptor signature. Also, we propose a simple transformation function to compress our global semantic representation of the object features in a low-dimensional global semantic signature. We propose a semantic distance metric as object typicality score. The experiments show that our CNN prototype model can capture the central semantic meaning of the object category. Figure shows an example of the semantic meaning captured by our CNN prototype model for members of number 5 category in this dataset. Note that our proposal can identify typical elements of the number 5. Our model also finds fewer representative members that it can be a 5 but not a typical 5. We used topology techniques for creating two continuous functions to feature mapping between feature domain using the object semantic value and our prototypical distance. The key idea is visualizing the category internal structure without discarding object features. The experiments show that even with different models and dataset, the category organization achieved in the descriptor signature domain is identical to category organization in features domain. Our descriptor signature preserves in its taxonomy the semantic information contained in the object feature extracted using classification models. Figure shows an example of signature taxonomies constructed with our descriptor using this model. Our semantic descriptor constructs each category signature distribution using, as signature generator, the category prototype. The prototype signature can be understood as a distribution or DNA chain that stands for the semantic meaning of the category. Consequently, typical members will have a semantic signature with similar representation to DNA chain of the semantic prototype. We evaluate the proposed semantic encoding of our descriptor against some image global descriptors in image clustering tasks. Table shows a screenshot of k-means metrics achieved by the selected descriptors in clustering of first 20 categories of ImageNet dataset. Figure shows the k-means metrics behavior of BGG features and our descriptor signatures, when the number of clusters is increased in each algorithm execution. The experiments showed that our semantic encoding significantly outperformed the other image global encodings in terms of cluster metrics. These results encourage us to evaluate the generalization ability of our semantic representation in other computer vision tasks.